Welcome in. We are back again. Yes, indeed. We are in Kindle Square. We are building a computer algebra system. Welcome in. We are going to first toggle our theme to something more amenable to sunlight. Yes, indeed. Okay. Let's close everything. So what is it? What is all the hubbub about computer algebra? What is it? Well, we can work with symbols. Yes, indeed. We can type in x and we get x back. We can say x plus 1 and it says, I don't know what to do with that. I don't know what to do. You tell me what to do. We are gonna nah. We're gonna keep it at 17 dB. But I can do this. I can say plus 1, 1, and it says, well, I have a rule for that. I know 1 plus 1, and so I give you 2. You say plus x, and it says, I don't know what to do with that. But maybe you could say plus with a pattern, and it stands for anything, and another pattern that's the same pattern, so x is equal to x in this case, and we say set that equal to times x2. Now, when we do plus xx, we get times x2. Now, what if we want to go beyond that? What if we want to do plus times pattern n blank int, close the times, then we say times plus n1. Now we can say plus x, we can say times x3 plus x, and we get times 4. And so with this, we can build up simplifying rules, you see? So that's the computer algebra system. And what we did last time is we looked into a famous book. You see, a famous book. And that book is called A New Kind of Science. And it's the science program. Okay? And we went to the crucial experiment, and we looked and we simulated the first 50 or 20 steps of this great system called Rule 30. And how many steps is that? 500, bruh? Damn. That would take forever in our system, wouldn't it? Okay, well let's dig in. Okay, so let's just go one by one. We are defining the rule. If you look at the rule, we can see that there's a Boolean form for each of the 256 elementary cellular automata, and this one so happens to land on Rule 30, which is the XOR of P with the OR of Q and R. And so here, if we write that in as our rule in systems, we say we got 3 arguments. See, P, Q, P, R. What? Hold on. It doesn't quite matter, right? It doesn't quite matter, but you know, a man like me ought to know what the alphabet is, and I'm pretty sure R comes after Q, but I could be wrong. But it doesn't matter because these Boolean rules, they're commutative. Okay. So anyways, we define this simple rule, and then we define a list form for it, so it could take a list of 3 elements. Yup. Okay, and we can see how we can copy in multiple lines of code into our program here. That's pretty sweet if you ask me. Then we define a function. We say, give me a value and give me a list. Here's the list. Here's the value. Ooh. We seem to have made a mistake. Join, that join works like the following. I could say, take a list of A and a list of B, and give me a list of A and B. Ha! Fancy stuff. Right? Now we define this, and it basically joins a list with the value on either side, so we can make sure that when we partition our list, we don't grow inwards. See? So now we define as let's say we set x's to range Ragnar 20, right? And now let's call little partition 3 for the number of elements in each object, and we take that and on the x's, and interestingly, we have this annoying fucking thing that has never seemed to cause me a problem. I'm going to comment this out. I'm gonna put on my hoodie. The sun's supposed to be shining. Oh, and for all of you Halloweeners, we can look at the weather and we can see. Oh wait, today's actually gonna be fucking nice, dude, and it's not gonna rain, bro. Oh damn. This is that Indian summer. Indian summer. Beautiful. It's so beautiful. It's going to be warm today, isn't it? Isn't it? Alright. So we have our partitioned list. What do we fucking do with it? That's the question. So now what we do is we map. We can do this. Check this. Map if onto x's. Now we get a list, and we take the arguments in x's, the list, and we apply f to each one. So now we have a function applied to 20 things. That's pretty cool, isn't it? What do we have next? We have so this function foo, which aptly named foo because everyone knows what that means, is first we take x as our list, which means one single row of our simulation. Then what we do is we pad forth onto the ends of it. Okay, then we partition. Then we map rule 30 to each element of the partition, right? See? I wonder how they make this fast. I don't know. Alright. Little sneeze. Now we set up our initial set to partition. That's good. Alright. Now we have a list of 20 or so falses, I don't know how many, and a single one in the middle. Single true. Where can we find it? Waldo. We found it. Now, here is the crucial part. We call nest list, which if you want to know what nest list does, we take a function like f, we give it an argument like x, and we say nest it 5 times. So we get x, then we get f of x, then we get f of x, and we go all the way up until we've applied. Oh, hold on. One, two, three, four, five. 5 times. Perfect. Okay, so now this will give us. Oh, seemingly forgot to define foo. Yeah, I don't know why. I feel like it wasn't doing that last time. Okay, but regardless, if we take the first part of ls, we get our initial condition. Take the second part, we get the simulation at step 2, step 3, and so on. So now I said, I want to make a picture of this. So first what I did is I said, let the pixel list represent the replacement of ls with all the zeros replaced with a list of ones, representing a white pixel. Bro, I thought there was a color picker. A white pixel, right. And then one representing a black pixel. This is kind of the opposite of what I would do, but it does make the picture look nicer. And then, okay, so let's do that. All right, so now we have our pixel list. Now we defined a function called export. Oh, wow. No way. Damn. That's crazy that it can do that. I feel like half my day is just spent refreshing stupid VS Code. Okay. Now we have our big list. Now I wrote in the kernel a function called export. Export takes a file name and an expression, and it renders it. And right now, we have this nasty bit of code that takes our list of lists or whatever and makes it a vec of these colors. Very nice. So what we can do here is let's call that function. And let's see, it makes a big SVG. That's pretty cool. We're using Cairo. Bro, if you're, bro, ban this guy. How do we ban this guy? This user's not been banned. Ban him. I don't want to see any of that trash on here. Okay, so now if we open up this file, we can see the result, the fruit of our labor, which is a wonderful picture of Rule 30. So beautiful. So now, yes, so how do I make the color red? How do we do this? That's an option? Or do we say red That's so interesting. I wonder if a function applied to a graphics primitive works. Yeah, no, but that would be crazy, wouldn't it? I don't know why that's not the. All right, well, let's try this. Really? And you put it in a list? That's interesting. I don't know how it lowers that. Okay, so what are we doing today? That's the real question. What are we doing? Well, I think we want this options thing. Let's see, how does manipulate work? And what is the. What the hell? It's pretty cool. This one doesn't do anything. No, that is so cool. Oh, cool. It's fucking rad. I don't know how to do that. All right. So I think what I wanted to do was pattern test. So we're gonna do pattern test. Okay. Okay. So hmm? Where was that page where it talks about pattern test? So I'm trying to find. Okay, so I'm trying to get better at describing the problem. So what we want is a way to be able to say, um, hold on. I want to add greater than and less than support. What's the full form of this? Ugh. So wait, what I should do is I should just say okay, fine. I'm just gonna add this in. Um, um, but so what happens if you do, or right? That's cool. All right, that's neat. That doesn't work at all. Hmm. All right, I don't know. I feel like I'm getting distracted. This is We do need comparisons, but the point right now is pattern test. And what I was trying to do is I was trying to motivate how pattern test works. I think it's in the options here. It's a pattern object that stands for any expression. Right. Right. So the it's kind of an interesting. Right. That makes sense. Because we don't have listable in our. We don't have listable. And so wait, so number Q also. Oops. Oh, number Q is not. Wait, what? No, yeah, right. You have to wrap it in the list. Again, the list of sequence. Yeah, okay, that makes more sense. Then this returns false. Okay. Okay, so I think it's possible. It's possible that the answer is a similar thing to this. And basically, you do this, where uh, cat1. I think that's correct. And let's just look at a full form. Right, okay. Then we say, we want to know uh, or we have I'm trying to think, because what do we need to apply number Q to? We need to apply it to what was matched. And we also need to I might have to cut this. I need to take it. I don't want to leave my computer out here. I mean, nobody is here. All right, whatever. I'm gonna end it real quick, and then I'm gonna hop back.